So in order to get ready for next class, I want to say just a little bit about compound functions. And I did an example with this in class, although I didn't use that phrase, when we were talking about inverse functions. And I mentioned that this function, 1 over 1 plus x, we could view as two functions put together. First, you take x and you add 1 to it, and then you turn the whole thing upside down. So what I want to do is just write a little bit of notation to accompany those words that I used. So the first function that gets done is we add 1 to x. That's the first thing that happens. And then the second function is we turn the whole thing upside down. And so I claim that I can take this function and I can write it as g of f of x. So when we have functions nested like this, it's a compound or a composite function, we evaluate from the inside out. So we start with x, we use that as the input for f, and we get something. And then that thing that we get is the input for g, and then we finally get our answer. So let me illustrate that with a number. If I plug in a number here, I think that will be clearer. So suppose I wanted to plug in x equals 7, just as an example. So I'll go over here. That's 1 over 1 plus 7. So now let's think about what we would do over here. So, well, I would do g of f of 7. And then you evaluate from the inside out. So I'd start with 7, and then I would do f to it. And in this case, fing 7 means adding 1 to it. 1 plus 7 is 8. Now I've got 8. I need to do g to 8, and I just look at what the rule tells me. It says take 8, turn it upside down. So turn it upside down, I get 1 over 8. So, and the left-hand side is clearly also 1 over 8. So the point of this example is, I guess, to illustrate that this way of writing this function as actually a combination of two simpler functions works, it makes sense. And also to remind you how to evaluate a compound function, you go from the inside out. So you start with 7, you do f to that, you get 8. You do g to 8, you get 1 over 8. So nothing really new, just some notation to accompany what I was talking about in class. So what we'll do next time in class on Thursday is we'll talk about some sort of special types of composite functions. By that I mean, suppose we have some function f of x. Maybe you have a graph. Who knows? Maybe it looks something like that. And then you could say, well, what would happen if I replaced f of x with f of x plus 3? What would that look like? Or if I replaced f of x with 3 f of x? Or if I replaced f of x with f of 3x? So, well, we can just plug in the numbers and just sort of be obedient and do what the function tells us, but would like to have some other way of thinking about what this does to functions, both in terms of what the graph looks like. So here's an old function and here are some new functions. And in terms of how we would think about it, how would we describe, just in words or conceptually, what the effect of these three alterations are. So in class on Thursday, we'll start maybe with another inverse example, just because those are kind of fun, and then we'll start exploring these sorts of questions. So we'll see you then.